So the approach I taught you was to look at both of these numbers, both of them in standard form, take out the larger power. In this case, it's 10 to the power of 1003. You factorize that out. Okay? The first number we are left with 3.6 times 10 to the power of negative 4. You can do a quick check. If you were to multiply 10 to the power 1003 multiplied by 3.6 times 10 to the power of negative 4, we will get 3.6 times 10 to the power of 999. Because 1003 minus 4, our very first law of indices, you multiply them, you add the powers up, you get 999. The second number, okay, since I factorized out 10 to the power of 1003, multiply it over here, we get 3.2 times 10 to the power of 1003, which is the same as the original question. Now that we are convinced they are the same, we just need to evaluate whatever is inside my bracket. So use your calculator to help you. 3.6 times 10 to the power of negative 4 minus 3.2, you will get a number that ranges, that is greater than or equal to 1 but less than 10. Okay, so in this case it will be negative 3.19964. Okay, so in standard form our answer will therefore be negative 3.19964 times 10 to the power of 1003. Okay, do this for your question 4A to D. That is what I requested you to do without your calculator. So I should see working like this. Any questions? Okay, do I need to round off this number over here? Yes or no? Why not? Do I need to round off? Who thinks I should round off this number? Who thinks I shouldn't round off this number? Okay, majority feel that you do not need to round off because it is exact. It is not a number that goes on and on forever and ever. So there's no requirement to round off. It is exact, write down the exact value. Okay, so now I will use this time to do one question from question 4A to D. You choose the question that you need help with. Question 4. Okay, if there isn't any request, then I shall move on. Is there a request from A to D? Using this approach. Don't be shy. It is your homework question, so if you need help, raise your hand now. None? Who is able to do it using my method and you got the correct answers from the back when you check? Raise your hand. Who managed to do it and got the correct answers? Raise up high, raise up high. Okay, then what about the rest? So this question is for the rest of you. If you need help, say now, I'll do one for you. Okay, so you're supposed to do this without a calculator. You got two numbers expressed in standard form. What number should I factorize out?
Negative 11.
What number should I factorize out?
Negative 11.
Not negative 11, what is the number? 10 to the power negative 11. We factorize out the bigger power. Okay, 10 power negative 11 is bigger than 10 power negative 12. So when I factorize this out, what do I have left?
5.4.
5.4 minus 6.6 times 10 to the power.
Negative 1.
What do you think? Is it negative 1? Is it 1? If you are not too sure, right, you can always try. Okay, let's say it is 1. If I have 10 power negative 11 times 10 to the power of 1, to the power 1, what do I get? 10 power negative 11 times 10 power 1, what do we get? 10 to the power negative 10. Is it the same? No, it's not the same. So it can't be 10 power 1. What if I put negative 1 over here? So now you multiply, what do we get? 10 power? What do you get? 10 power negative 12, which is the same, isn't it? It's the original question. Okay, so this is what we have. Next step, 10 power negative 11, evaluate what is inside your bracket. 5.4 minus 6.6 times 10 to the power of negative 1, and we should know that it is actually 6.6 divided by 10, 0.66. So we end up with 4.74 inside here. Final answer 4.74 times 10 to the power of negative 11. This is in our standard form. Is the answer correct? Okay, so this is the approach that we can always take, regardless of whether it's a plus or minus, whether you are adding two numbers or subtracting two numbers, or whether the powers are positive or negative, the approach is the same. Just factorize out the larger power. Okay? Now with that, I shall. Are these the same thing? Are they the same? R% and R, are they the same thing?
Oh.
Okay, what about this? Are they the same?
Yes.
Okay, you are right. So you must know the difference. R% is not the same as R, but R% is R over 100. Okay? What does the N over here stand for? The years? Is it the number of years? So far, your simple interest, right? Is it always given to you 5% per annum, 3% per annum? Has it always been the case? Then they always tell you, oh, calculate the interest after 10 years, or so on and so forth, right? Have you seen a case where they say the interest rate is 3% every 6 months? Have you seen something like that before?
Oh.
But they can, right? They can give you such a question. Then they will ask you, oh, what is the interest after 1 year, for example? You know how to convert? So after 6 months, you get 3%, for example. Another 6 months, you get another 3%, isn't it? So this N over here will no longer be the number of years, it will be the number of times that we get our interest, isn't it? So in this case, if it is 3% every 6 years, then the value of N after 1 year will be 2. Because 6 months, did I say 6 years just now? I meant 6 months, okay? 6 months you get interest one time, 6 months you get another interest, okay? So you need to know that it is not always the case you get how many percent per annum. It could be per month, so on and so forth. Okay? So that is for simple interest. Now I need to check your understanding for your simple interest. Okay, flip with me to exercise 1.6. Exercise 1.6, question 1. Just do it in your textbook. Part A and part... Okay, let's just do part A. Okay, 1A. Fill in your textbook now. This is our simple interest calculation. Do you think banks charge you based on simple interest? Continue. Is that what you learned in lower sec for simple interest? Or are you answering my question about banks? Okay, can you explain? Can you try explain to class what you were trying to say? 10 minutes left. Now our banks, they don't charge us based on simple interest. In fact, they do something similar to what Sihan has said. Okay, it is based on the 100%. The principal keeps changing. Okay, every time they calculate the interest. Okay, so this is what we are going to find out now. I'm going to draw a table. We are going to try and fill in the blanks together, yeah? Okay, so this is the year, 1, 2, and 3. Principal at start of year. This is the principal at the start. Interest at the end of the year. And finally, total amount at the end of year. Okay, so let's try with a simple, convenient number. I believe our textbook has something like that. Okay, on page 27, let's say our initial principal, $2,000. I am going to put $2,000 inside, and the interest rate is 5%. Okay, 5% per annum. Okay, what is the amount of interest at the end of the year 1, year number 1? Using our simple interest formula, okay, just for this instance over here, we've got 2,000 times 5% times 1 year, isn't it? Okay, so I don't bother writing the 1 over there, and this gives me $100. Following so far? Okay, so the total amount, obviously I add them up. So 2000 plus 100, right? So that's 2100. And you notice that your textbook, they wrote it slightly differently. They wrote down 2000, then 1 plus 5%. Do you understand why they wrote that? Okay, we do know that this total amount is supposed to be 2000 plus the interest, which is 2000 plus 100. The reason why the textbook represented it in another method, in another way, is because, let me just work it out for you. We are supposed to take 2000 plus the interest, right, which is 2000 times 5%. Right? This is supposed to be the total amount I get. So if I factorize it, what is the common factor? 2000, obviously. Take out 2000. I've got 1 plus 5%. Agree? Agree? So this is just one way of writing 2000 plus 100. Okay? And it is important. I'll show you why later on. Now, at the end of year 1, the amount of money is 2000 plus 100, which is 2100. Naturally, I want to write 2100 over here. My money grew. In the second year, do you expect the interest to be more or less than compared to the first year?
More.
More. Why?
Because you have more money.
Because your principal is more, right? Just by thinking about this, do you think compound interest is better or simple interest is better?
Compound interest better.
Compound interest better if you are saving money. But if you are taking a loan, compound interest is not good for you because you will be paying a lot of interest. Understand? Okay, so instead of writing 2100 over here, we have seen that we can actually write it as 2000 1 plus 5%. Okay? This is the same, huh? 2001 plus 5% is the same as 2000 plus 100. Now the interest at the end of the second year. How do we calculate the interest? 5% per annum, right? This time it is 5% of your new principal. The new principal is Darius. How much is it? How much is your new principal? Can't hear you. Just read. Don't need you to calculate anything. 2000? What? 2000 times 1 plus 5%. Yes, correct. So now the interest at the end of the second year, we take the principal multiplied by 5% again, isn't it? Okay, let's do that. 2000 times 1 plus 5%. 1 plus 5% times 5%. Agree? Okay, now I need to add them up again. I need to add these two up in order to get my total, right? Okay, so if I were to add them up, I get this. 2000, 1 plus 5% plus 2000, 1 plus 5% times 5%. Agree? Agree? Simple addition, huh? Can I factorize again? What can I factorize out this time?
5%.
5%, are you sure? Are you sure I can factorize this? What should I factorize out? 2000. Is this the only thing I can factorize out? 1 plus 5%. I factorize these two out, right? So from my first number, after I take out 2000 times 1.5%, what am I left with?
5%.
No, the first number over here. This number, I factorize out 2000. I factorize out 1 plus 5%. What am I left with? 1. I'm left with 1. Okay, so that's 1. In the second number at the bottom, I factorized out 2000 and 1 plus 5%. What am I left with? Yeah, 5%. Okay, so this is what goes into this box over here. But do you notice that 1 plus 5% appeared twice?
Yeah,
So can I simply square it?
yes.
Yeah, I can. Okay, so let me just write down the summary over here. In the first box, I have 2000, 1 plus 5%. In the second box, I've got 2000, 1 plus 5% squared. Okay? Now, we could have calculated the exact values. In the first box, it will be 2100. In the second box, it will be something else altogether. If I continue to do this for year 3, year 4, year 5, What do you think I will get
3, 4, 5.
on this part? This is what I'm interested in.
The 1 plus 5%.
Okay. Looking at the pattern, I think I will get 2,000. 1 plus 5% to the power 3. That is at the end of year 3. At the end of year 4, so on and so forth, you can see the results in your textbook, page 27. Okay? So this is the derivation for the compound interest formula. You have learned simple interest formula. This is our compound interest formula, and it is found on page 28. Okay? I will write it out for you. AN equals to P1 plus R over 100 to the power of N. Right. So this is my compound interest formula. Let's understand what AN stands for. AN. Pay attention. Total amount after N periods. This is actually our principal plus interest. Principal plus interest. Okay? Oh, sorry. PAL. Principal plus interest. This was obtained from our last column. When we wanted to calculate the total amount at the end of the year. The total amount includes your principal, it includes your principal, yeah? So, that's what this formula gives us. Okay? This little n over here refers to the number of periods. Remember when I mentioned simple interest? There is also a letter n, right? It is referring to the same thing, number of periods. Now P over here is our principal, no change. 1. Simply a constant. It appeared everywhere here. So you got principal multiplied by 1 plus the interest rate R over 100. Okay, this is the same as R percent. Compare it to our previous table, we've got 5%. Okay, and we've got the power N over here. That refers to the number of periods. So N equals number of periods. Alright? Okay, so we're going to do one quick example on Try It 20, part A. Okay, your bell is going off. We just need less than 1 minute for this, can? Then we are done for today. Sum 8,400, that's our principal. Invested interest rate 9%, R percent equals to 9%. Duration 6 years. So find the interest. Remember, our formula gives us principal plus interest. If I just want the interest, I need to remove the principal. So let me just write out A, N. In this case, N is 6, yeah? Okay, so this is the total amount after 6 years. I have 8,400 multiplied by 1 plus interest rate 9 over 100 to the power of 6. This is the total amount, which gives me, using my calculator, 087.64 dollars. Okay, there should be some more decimal points, but you can round it off to 2 dp. Now, interest is going to be A6 minus our principal of 8400 to give me 5687.64 blah blah blah, round it off to 5687.64.